Hi, everyone. My name is Andy Troutman. I'm a senior manager here in AWS, mostly focused on our developer tools. And in particular, I look a lot at our deployment systems and how both our internal engineers as well as our customers get their applications into the cloud, either EC2 or some other compute resource like ECS, containers, or other serverless technologies like Lambda. Today, I'm going to talk about how Amazon changes our code. So we'll look at the life of a code change to a tier 1 service within AWS. I get this question a lot. Every time I have the opportunity to meet with customers, I'm always asked about how Amazon deploys our software and how we manage change in our own internal infrastructure. I always ask customers, why do they care? Right? Why are they interested in the way Amazon manages our infrastructure? Chances are the company that Amazon is with our culture and the way we manage things isn't always applicable to the way other businesses manage their content and their own application lifecycle. But what I've come to realize over the years is that many customers think that the way Amazon delivers and deploys software looks something like this, right? There's a magical unicorn that we keep locked up, and it ensures that every piece of code that we write is flawless. It scales infinitely, and it's really magic, right? It keeps everyone safe and ensures that no matter what Amazon does, it always works out the best for our customers, and thus we can move so quickly and get everything done. The reality is, from the outside, Amazon does look rather impressive. Amazon on any given year does well north of 50 million deployments a year. We have tens of thousands of developers and builders located all over the globe, constantly submitting software. This adds up to more than a change every second in Amazon's ecosystem. So we're deploying code multiple times a second, every single day, 24/7. So, it is a massive scale that we've been able to achieve. But the reality is that Amazon's culture is much less than magic and much more like sausage making, right? So there is no magical unicorn. There's just a lot of tools and best practices that we've adopted over the years and approaches to the way we do software development that really is the magic inside of what makes Amazon successful. So I always tell people, there is no unicorn, but I can tell you how to make unicorn sausage. Much of what enables Amazon is our tooling culture. So I would say that the thing that has allowed us to scale and to be so successful is the fact that we have invested so much in automation systems to help us manage our infrastructure and our ecosystem. This is good news for you as a customer, because if you want to steal the unicorn, so to speak, steal Amazon's secret sauce, what you really need to do is learn about how we use our own tooling and how we manage it, how we use it to manage our infrastructure. And then what I would tell you to do is not just to copy exactly what Amazon does, but to adapt it to your own culture and your own way of doing things. And I would argue that you can actually build a superior release process to what Amazon has, because you can customize it and tailor make it to what you as a company needs. So a quick slide to go over what we're going to talk about. We'll talk about the technical and cultural landscape here in Amazon. I think to understand how Amazon manages our own services and applications, we really need to look at culturally how Amazon is set up, as well as some of the technical details. We'll talk about Amazon's tooling philosophy. We take a very different approach to the way we do internal developer tooling than a lot of companies our size. Then we'll go into the actual release process. We'll talk about code reviews, the build process, a process we call the pre-mortem. We'll look at pipelining and the actual deployment process, so putting bits onto compute nodes. And then we'll talk as well about how we actually manage infrastructure. So not just the code, but the servers and the configuration and all of the other details which make a healthy and successful application. And then we should have time at the end. I'll offer a final set of thoughts, and then we'll be able to cover QA. Okay, so before we dive in, let's meet the hero of our talk. So if we're going to talk about how to make a change to a tier 1 service, we need a change. And I think for the purposes of this talk, the nature of the change is less important because, as you'll see, consistency is really the emphasis of how we manage software in AWS. So every change goes through the exact same process. It's repeatable, it's automated, and it happens for everything. So whether or not this is a large, complicated change or a single line of code. Everything goes through the same process. So as we go through, you'll see our hero, our change, and we'll talk about how it makes its way all the way to production. Before we get there, let's talk a little bit about Amazon's technical landscape and a little bit about our culture. So Amazon, as many people have heard, is famously a very web service-centric company. We believe in the model of building small teams that can act with a lot of autonomy. The teams get a lot of decision-making power. And in today's ecosystem, the average size team at Amazon is still just 8 engineers big, right? So we believe that's a really good number. It's large enough to get a lot of work done, but it's not so large that you suffer from an overly high communication burden between all the engineers, right? So we like small teams. We think they are more agile, and they can get a lot more done. The other aspect of Amazon's culture that's really important to how we develop and how we release code is this ownership model that we have, right? So as I said, we build teams around web services. We try to build relatively small teams, and then we focus on empowering those teams. So an individual group, I always tell people that Amazon is structured more like a federation of startups than it is an individual company, right? So each of these teams is given a lot of decision-making power. They're empowered to pick the technology they use. They're empowered to pick the ratio of different job roles, so the ratio of engineers to managers to product managers. They're asked to define their own business metrics, to define their own operational metrics, and really to figure out what success means for their customer, right? So they really are given a ton of autonomy and independence to operate. And with that autonomy and independence, it allows us to move very quickly, right? So they don't have to run every change through a decision-making process. Because they run their own technical stack, they are free to move relatively quickly in absence of other dependencies. And this enables us to move very quickly. So I'm not going to talk a lot about the local development process, but I have one single slide which kind of, I think, encapsulates the details that matter. Because we've built these highly autonomous individual teams, this federation of startups, you will not see a consistent software development methodology in Amazon. By and large, agile principles incorporated in a lot of different ways. At Amazon, what we really care about is that you're shipping in an iterative fashion. So as soon as you get something that's viable, put it in front of customers, listen to their feedback, learn from it, and then iterate there. So we're big believers in pushing code frequently to customers, learning from the customers, and then working to address the customer feedback. The process, which I'll talk about in a little bit, is really how we ensure that we don't cut corners from a quality or consistency standpoint. The process is really geared towards ensuring that we can move very quickly and we can iterate fast and we push things out the door all the time. The other thing that's interesting about Amazon is every individual developer box really is a copy of the web services that we're constantly developing, and we can use that to our advantage. We can connect an individual developer box into a beta or a gamma environment and have it participate with all of its dependencies, right? So it can act just as if it were a production box. This enables us, again, to do testing and development in a really rapid cycle. It allows us to maintain consistency between our dependency chain and the ecosystem of other web services that we leverage without having to push everything all the way to production and test it. So again, really focused on moving quickly and letting engineers iterate as fast as possible. Let's talk about the tools. So I've been alluding a lot to the process and the tooling in Amazon. Let's talk about the philosophy that we have within Amazon. So as I said, everything in Amazon is as much as possible automated as best we can. But this is a challenge because our ecosystem is not homogeneous, right? As I said, every team is empowered to pick the technology and the approach that they think will work best for them in order to deliver value to our customers. And so the tooling needs to be very flexible. So a lot of our software management tools focus first on being general building blocks, right? So that we do the simplest thing that we possibly can. Our pipelining tool lets you visualize a linear flow of a single software release. Our deployment tools put bits on a box or on a compute node and let you run some scripts. Our build fleet has a couple conventions about how we execute your build logic, and then very little else, right? So we start with very simple primitives, building block services, and we make them highly extensible and highly flexible. Then we turn them loose on our developer community. We ask every team to use the foundational tools and to extend them to meet the needs of their business as much as possible. What we end up with is an open marketplace inside of Amazon, right? So every team is taking our building block services, extending them, adding to them, investing in them. And what we see over time is that certain patterns and certain values emerge, right? So we take these incredibly simple tools, and then as people start to build on top of them and use them, we can actually fund winners in this internal ecosystem, this internal marketplace. So as we see certain testing approaches or validation processes or additional build information, et cetera, emerge in this open ecosystem, we'll seek to fund that by pulling it into the centralized tool and making it common and available for everyone. And so as you'll see, as we talk about Amazon's release process, we take a very simple idea, and then over time, we kind of build best practices that we learn through usage and repetition in our ecosystem to improve them. So let's meet our antagonist. If the hero of our story is our change, the villain or the protagonist must be the process. So everything in Amazon goes through the same release process. The process is intended to ensure that every piece of code that gets checked in and ultimately presented to our customers in production goes through the same mechanism. From the perspective of the process, our change is outright evil, right? So the process is always assuming that any change is by its nature nefarious, customer harmful, and downright dangerous to put into production, right? So the process takes a very negative stance towards every piece of software change. And the process's job is really to try and kick change out of the pipeline as quickly as possible. This, on the surface, might seem like it would slow us down, but in reality, it allows us to move very quickly because we have a lot of confidence in our process. We know that the process will prevent things from making it to our customers which shouldn't, and it allows us to push things out the door in rapid fashion. Likewise, when the process kicks something out, we just take the next change in the pipeline and introduce it and start pushing it through the release process. So this allows us to push a lot of change to the system in rapid fashion. Let's start taking a look at some of the tools. So our change, our piece of code, is going to start in a Git repository. Most teams in Amazon use Git as our version control mechanism. And as I said before, so Git is sort of the foundational vanilla version control system that we use in Amazon. But most teams at Amazon don't just use Git directly. They use Git farm. So Git farm is our internal version of Git that we've invested in over the years. And so the common, the building blocks is Git, and the things that we've invested in that make Git more valuable to us are a bunch of things. So if you're an engineer and you push code into Git farm, you get a lot of extra advantage that you wouldn't get with vanilla Git. The first thing you get is replication. So anytime you submit a change into our Git repository, it's actually duplicated in triplicate, and it's pushed throughout the world to ensure that we never lose intellectual property, we never lose code. Also, we added much more fine-grained access control onto Git. So vanilla Git access control is not as fine-grained and is not as fine-tuned as we wanted, and so we actually have invested the ability to, all the way down to the file and branch level, control access to individual changes. This allows us to protect pieces of code that we don't want everyone to have access to. It allows us, again, to move very quickly by not having to manage access outside of the version control system. And finally, any piece of code that you push into our Git repository is automatically indexed and searchable, right? So code search, we we believe is an incredibly valuable aspect of a healthy culture. We encourage engineers to go learn by searching the code repository and seeing what others are doing. And if we really want that to be seamless, we want to make sure that every single check-in and commit is rapidly indexed and made part of the code search repository so others can learn from it. I'd be remiss if I didn't tell you that many of these advantages that we've baked onto vanilla Git aren't also available for you as an AWS customer. So code commit has many of these same advantages. It also replicates your bits globally in triplicate to make sure things don't happen to them. It has much better access control primitives than vanilla Git. And you can also use it to index and search things. So now we have a code change. So we've introduced a change into our version control system, and now we want to begin the process of releasing it. So we want to take our change and begin to move it through the process in order to get it all the way to production, ultimately to our customers, so it can start adding value. The first place we begin is with code reviews. Amazon is a big believer in code reviews. If you look at our code review tool, it's nothing exciting. It's exactly what you probably have in your own internal systems. It's a list of changes and the ability to comment on those changes, and eventually you're able to signal that a change is ready with a ship it. So that's the vanilla version of code review that we all use. Some of the things that we found that ended up paying a lot of dividends for us is that on top of our vanilla code review system, we actually built a pretty robust rules engine. This rules engine lets us create rules about who and how many and what rules and things like that need to review or sign off on a piece of code before it gets pushed. Because we want the process to be as fast as possible, and because humans always slow down a process, we want to try as much as possible to front load any human auditing to the very beginning of the pipeline and get it out of the way. The rules engine allows us to ensure that certain things happen, right? So we can ensure that particular code paths or branches are reviewed by at least one senior engineer or perhaps multiple senior engineers. If we have compliance or auditing mandates, we can ensure that special roles can also are signing off on code at review time rather than later in the release process, right? So if we have an auditor or an auditing role, we can ensure that an auditor signs off on code at review time rather than waiting for it to make its way all the way to production to discover that we have a non-compliant piece of code, right? So we front load that as much as possible. And the rules engine that we've built on top of our vanilla code review ensures that the right things are happening. Once we've got sign off on a piece of code, so the right number and the right roles have reviewed the code and said that it's ready to go, we typically go through a build process or a packaging process, depending on whether it's a compiled or an interpreted language. But at the other end, essentially comes the set of artifacts that we're going to use to release our code. The build, again, the simple version of build is we take a set of packages, we look for the build script and we invoke it, and we look to see if it succeeded or failed. And then we've scaled that to be able to build many packages in parallel, as fast as possible. But again, Amazon has taken a little bit of a different approach over time. So some of the things that we've baked into our vanilla build process, of course, unit testing is executed at build time. We also invest a lot in static analysis tools. So we do a lot of static analysis, find bugs and memory analysis. We also, at build time, can analyze the dependency closure of the code that we're getting ready to ship, and we can look for known bad versions of dependencies, right? So if a team is depending on a version of software that has known security vulnerabilities against it, or that we, for licensing reasons, don't want into our ecosystem, we can actually proactively block that software at build time, right? So this again ensures that we're, as much as possible, catching problems and preventing them from getting into the release pipeline as early as possible, right? So we can actually say, this version of Spring or Ruby or whatever it is no longer valid as a dependency within the ecosystem. So before you can release a new version of your code, you really need to take the time to upgrade this dependency. We're able to do this because Amazon, unlike a lot of companies our size, still has a global dependency closure. So company-wide, we still look at one dependency closure that we all depend on. And this gives us a ton of value in the form of being able to figure out which teams are depending on which versions of software and able to take actions kind of company-wide across the entire ecosystem. There are disadvantages to a global dependency closure. It certainly makes it harder to build. We build against all of our dependencies, and that can become very expensive if you're building a very low level or foundational library. But we believe that the advantages outweigh the disadvantages. It allows us to quickly identify who is using what code, and if we need to take a remediating action, we can reach out proactively to those teams. So we've got a piece of code, it's been reviewed, it's been built, we've done all of the unit testing and static analysis, and we know that the code is using blessed versions of software dependencies. So now we're actually ready to start the release process. The first thing we do is that we have a process that we call a pre-mortem. In a pre-mortem, I'm sure many of you are probably familiar with post-mortems, which is once something goes bad, you go through the why process, right? You ask yourself the 5 whys. Why did this bad thing happen? How could we prevent it? You look back at the change and try and figure out how you could prevented the outage or whatever the unfortunate incident was from reoccurring. For particularly sensitive code changes, so code changes to a tier 1 service, something that's very foundational to the way Amazon works and functions, we will actually do a pre-mortem. So before we release a piece of code, we'll get senior engineers into a room as well as the junior engineers, and we'll talk through the release. What does this piece of change depend on? What is the TPS that we're expecting? What testing has it already gone through? If we have a problem, how do we roll it back? So what are the mitigation steps? We walk ourselves through the entire process and ask ourselves, what happens when this goes wrong? And we get a lot of value out of this. We actually catch a lot of things earlier. And even when we don't catch things before we release, the time to mitigate a problem is drastically reduced by going through this pre-mortem process because we've already codified all of the steps we need to do to take a quick remediating action. Now, pre-mortems don't scale to every single software release. We would not release once a second if we did a pre-mortem for every single change. But for highly impactful code changes or very large code changes or changes in behavior, we find that it's worth the investment to really sit down and slowly walk ourselves through the change process. Okay, we've got a piece of code, we've reviewed it, we've built it, we've thought about how we're going to release it. It's now actually time to begin the journey, right? So now our change is going to begin the journey from a developer desktop into our testing infrastructure, into our integration environments, and then ultimately into production, into our customers' hands, which is the ultimate test of whether or not something works. So a code change in Amazon doesn't just go to a single set of services, right? If you're an AWS customer, you know Amazon or AWS is really a global footprint, right? Just to motivate this a little bit, AWS is in 16 regions, which are distributed across the globe. Within those regions, we have 54 availability zones, which are individual compartments of compute technology that we want to, as much as possible, ensure fail in isolation. If we include CloudFront POPs, that's another 100 plus places that we need to deploy to. And this is just for AWS, right? So this is just the number of places we need to update a piece of code for the Amazon business or for the AWS business. Amazon Retail has its own set of compartments and its own global footprint, right? So there is a ton of places a piece of code needs to make its way to. If we tried to manage this in a manual way, so just imagine that if you took the poor intern on your team and said, I want you to release a single line of code change, but it has to go through 16 regions or 52 availability zones and 100 CloudFront pumps. just write a list of them and one at a time go through them. It's completely unsustainable, right? So it would be impossible to manage at this scale in a manual fashion. And so what we use is pipelines or code pipelines if you're an AWS customer, which is a tool that we use to visualize and manage the release of any piece of software. So what you're seeing here on the screen is a screen capture of one of our pipelines. This is a pipeline for one of my teams. You can see on the, I know this is very small text, but on the far left side is where a code review and a build begins. And then each of those vertical columns that you see is another stage of our software release process. And what you'll notice is that it's actually cut off on the right-hand side. So this isn't even the entire pipeline, right? And within each column, you see the set of validations that's happening, right? So the deployment, as well as any manual sign-off, as well as any testing that's being done for each of those stages in the pipeline, right? So as I said, if we had to manage this by hand, completely unsustainable. So we needed to build a tool which would let us visualize a release or a code change, and ultimately to automate it, right? So this is not just the visualization, but this is actually the plan of execution, right? So this tool is ensuring that every single code change goes through the same consistent process every time we release something, right? It's built in the same way, the same set of tests are run, it's deployed to the same set of regions first, same set of availability zones, et cetera, right? So this consistency is incredibly important to being able to go fast and to be able to raise the bar on the quality of the software we release. So this is the process made visual. Let's talk about some of the release primitives. So as I said, pipelines, you know, the most simple form of pipelines is just this linear view from left to right of what's being released. Over the years, though, we've identified some basic primitives that are part of that release process that we found incredibly valuable to manage Amazon's software change, which we think will be valuable to use customers. The first is manual approvals. Amazon loves continuous delivery and continuous deployment. We want all teams to get there, but we also know that if a team isn't ready with the right set of checks and balances and validation to continuously deploy, it's much more impactful and it's much slower to move to a continuous deployment model before you're ready. So we introduced this concept of manual approvals. Manual approvals are a way to pause the pipeline and wait for an individual to make a judgment call. We also use manual approvals for compliance reasons, right? So if we can't meet all of our compliance and regulatory checks and balances at build time or at code review time, we'll push them into the release pipeline. We'll actually cause the release pipeline to pause in certain geographies or certain availability zones in order for the right people to sign off on the code release. Time windows are also important. Everyone has that horror story. Hey, remember the time that we released that piece of code on Friday afternoon and then it went bad, and before you knew it, it was Saturday afternoon and everyone is in the office and everyone's sad. Amazon hates that story. We all hate that story. And so we worked really hard to ensure that we release software at the right time. For us, the right time is during business hours. We want engineers present, we want them awake, we want them paying attention. So we release software, you know, typical 9 to 5, Monday through Thursday. Friday, we knock off a little early. Usually for most teams, the last set of software changes have to be out the door in the early afternoon. So we have time to fix problems should they arise. Testing tasks, as you could see in that pipeline, there were many different sets of validations that happen. Amazon has a ton of different testing mechanisms. We have simple unit testing, we do integration testing, functional testing, scale testing. So we'll fire a bunch of requests at a new code path or a new web service. We also have the ability to ensure that a code path has been executed a certain number of times before we proceed. We find this incredibly valuable. What we find with a new feature or a new piece of code is that it doesn't have the call volume of something that's already been in production for a long time. And so to build up the confidence that it actually works as intended, we'll actually enforce that the code has to be executed successfully a certain number of times, see a certain success rate or a certain latency or error rate threshold before we can proceed. All of these different types of tests are captured in the form of plugins into the pipelining system. Global and-on chords. For those of you who are not Lean Six Sigma junkies, an Anton cord is this process that's been instituted in a variety of places, which allows you to stop a global process, right? It's most famously comes from Toyota, where they gave their car manufacturing assembly line the ability to stop the entire assembly line for any particular issue of quality or safety. When they did this was incredibly controversial. The old mentality was stop the line for nothing, we'll fix it later. But because they wanted to take the issue of quality and safety so importantly, they ensured that any line worker could stop the process. We have the same thing for our release pipelines. We have a global Anton cord, which allows anyone who believes that there is a change that's about to impact the company or a large swath of the company to pull the Anton cord and stop it, right? So we can actually pause the entire release pipeline at any point in time. And we do it occasionally. Sometimes we proactively put in blockers to ensure that we're not deploying at sensitive times for our customers, right? So Black Friday, as you can imagine, is a very sensitive time for a lot of AWS customers. We ensure that we're not making a bunch of changes to the services that our customers are depending on during this critical period. Attribution and roles, we want to make sure that any piece of change that is going through a release pipeline is attributed to a team, an individual, and a particular role. This, again, is so that we can ensure that regulatory and compliance mechanisms are met, right? We want to be able to say that the people in charge of this piece of software are also the people who are managing the release of that software. So those are our release primitives at the pipelining level. So that's how we let change enter into the system. Let's also look at the deployment level. So what are the primitives that we've invested in as a company that we think have paid a lot of dividends for when we release code onto a compute node, right? So an EC2 instance, or a container, or even a serverless function, right? The first one that we built very early and has continued to pay dividends is automatic rollback, right? So as you're rolling out a piece of software, if at any point in time an alarm goes off, so it could be a CloudWatch alarm or a metric or any other thing that you're looking at that deviates from the norm, we can quickly detect that and we can issue an automatic rollback to the deployment servers to undo the change. This drastically reduces the time to resolution. The alternative would be to have an engineer notice that a problem is going on and then begin remediation. We know that we've saved hundreds, probably hundreds of thousands of hours at this point of outage or of impact to our customers by ensuring that we automatically roll back any kind of deviation from the norm as part of the release process. Incremental release. So if I have 6 servers to update, a very bold strategy is to update them all at the same time, right? This is an all or nothing strategy. So when you release software, if it goes well quickly. But when it doesn't go well, you've really increased the blast radius of the problem, right? Instead, Amazon takes an incremental approach to releasing software, right? We release to a subset of our capacity first. We monitor it, we test it, we ensure that it's working as expected, then we do a little bit more, then a little bit more. And as we go, as we're building confidence, for a very large fleet, 6 isn't particularly big, but if we're deploying to a fleet of thousands, we'll start to accelerate that incremental release cadence. Again, we found that this has been incredibly valuable. We detect problems early on 1 or 2 nodes. We can roll it back before it causes broad customer impact. Health tracking. Health tracking is keeping track of the state of every individual node. So our deployment systems, both CodeDeploy for AWS customers as well as some of our internal tools that we use within Amazon and AWS, keep track of the state of every individual node. So let's pretend we're rolling out a change and something goes wrong, and we roll it out to half the fleet. At this point, what we need to do is we need to remediate the issue. We need to either roll back on those nodes or we could roll forward with a new change. Either way, what we don't want to do is we do not want to touch the blue nodes, right? We do not want to touch any capacity that's using a working version of software because that actually increases the blast radius of the problem. because we, at an individual compute node or instance level, know exactly which version of software is running on every single node, we can prioritize known bad nodes, upgrade them, fix them first, before we continue to roll out a change to the rest of the fleet. Health tracking, again, allows us to pinpoint the problem and target the solution much faster than if we just naively roll a change out across the entire fleet. Change provenance, just like we need to understand who is executing and releasing change in a release pipeline, we need the exact same thing for the actual code that's being put onto every individual compute node. So we want to know who approved the code, what process it went through for validation. We, of course, do checksumming and validating that the bits that were checked into our revision control system and then built are the same ones that end up on the end host, so that we can actually say, like, across the entire thing that we have a secure system, right? So we can do change provenance from the time a piece of code is checked in all the way to every individual node it's running on out in the fleet, what the software is, who approved it, who made contributions to it, et cetera, et cetera. This is no small feat when we start to operate at this scale, right? So being able to keep track of every single node and every single piece of software that's on it can get quite expensive. But again, it pays dividends. It allows us to move very quickly to remediate issues when we detect them. So those are some of the release primitives that we have across the deployment system. So both the release primitives that allow us to manage at a higher level the release of a piece of software into the various availability zones and regions that we have, as well as all the way down to the individual instance, EC2 instance level, what exactly is happening as part of a change. As you can see, this process is very rigorous. It's got a ton of checks and balances in it, and it's because of this that we can move very, very quickly. So let's talk about managing infrastructure. So at this point, we've kind of made it, right? Our software has gone through the entire process successfully. It's gone through every single check and balance we introduced, and now it's made its way all the way to production. But the job isn't done, right? So we also want this exact same process for changes to our underlying infrastructure and its configuration. So we pipeline and we use our pipelining tools to make infrastructure changes in the same way we make changes to software. So if we want to increase the number of servers in production or decrease, or change the version of the AMI that they're running, or change the memory allocation, if we want to introduce a queue or a new DynamoDB table, all of that is controlled through a pipeline which uses a templatized system like CloudFormation, for example, to manage that release infrastructure. So we get this process, again, is reusable for many different use cases, right? We can ensure that the same release order and the release cadence that we make for software is honored by any infrastructure changes. Likewise, we can have those infrastructure changes roll out slowly, we can detect problems, and we can proactively roll them back. This is incredibly powerful. As you get bigger and bigger and you need to manage more and more infrastructure, consistency in your infrastructure is just as important as consistency in your software process. So now we've truly made it, right? Our code has made it all the way to production. Our infrastructure changes have made it all the way to production. We should be sitting pretty. But not true. The process's job is never done. Even once we've made a piece of change all the way through our release process into production, we still need to continuously monitor it and validate it. Because the reality is that the world changes underneath of a piece of software. New security vulnerabilities are found. New best practices emerge. Configurations are discovered to be inefficient or harmful or dangerous. All of these things introduce new best practices and new changes that we want to monitor and proactively capture. So we actually have continuous auditing and monitoring practices within Amazon. And, this is just another screenshot of a tool we use. This is a tool that we use to keep track of the risks that we have within our ecosystem. So as I said, as new risks emerge, we can actually see the number of release pipelines and servers that are impacted. We can track change over time. We can see Are we getting worse, or are we getting better? So are we remediating the risk in our production environments, or is it continuing to grow? And we can actually audit this and improve it over time. So I think this is really important to our success, right? It's not just about releasing quickly, but it's also about ensuring that best practices are quickly adopted, right? So we want to make sure that we evolve our processes, even on the things that are out in production, as quickly as we can. Having tools that highlight the potential for improvement really allows, again, all of these autonomous individual service teams to take action quickly and to kind of control their own destiny. So I think we finally made it. Just to kind of summarize one more time, I think the things that have made Amazon successful and have allowed us to move so quickly and to develop so much software for our customers. The first is that Amazon standardizes a ton on our software development process via common platforms. I've talked about some of these platforms today and how we've extended them. We make those platforms better by encouraging an open marketplace. So as I said, we build very simple primitives, and then we encourage people to optimize them for their particular use cases. When we see optimizations that are working really well, we pull them into the centralized tool and we make them available for everyone to use. We ship so much not because we move dangerously fast, but because we have a process that allows us to kick changes out quickly and to continuously push the envelope. Amazon is, of course, we're doubling down on our tools. We continue to invest both in our internal tools as well as our external. And more, the internal ecosystem is being taken over by the code suite, by CloudFormation, by the exact same tools that we give to our AWS customers. So if you are using our AWS management tools and services, you're using the same tools that Amazon is using more and more. And we believe that that's the way that we're successful, and we hope that it enables our customers to be successful as well. So I think that's all the time I have. We have a little bit of time left to take questions. So I'm going to sign off for now, and then I'll take any questions the room has. Thank you.